Hey folks, so today we have another refrigerator that I trash picked yesterday, and trash picked this one kind of against my better judgment because when I opened the doors it was absolutely filled with little, I guess it was maggots or fly eggs, I don't really know. So that's why you don't see any shells in here. I put about 300 gallons of water through this just to get the obvious ones out. I let it dry overnight. I mean, there's still flies in here, so there's obviously some that I didn't get. I can see visible flies, and yeah, it's bad. So before I spend any time cleaning it further, I want to see what's wrong with it. And all those little whitish flecks that you see down there that you probably can't see are moving are actually moving. So this fridge is very much alive still. But again, let's see what's wrong with it. Have the ice maker unplugged, or I have it turned off because that got really wet yesterday. I let it sit in the garage with the fan going on it all night with the air conditioner on dehumidify. So let's plug it in and hope the magic smoke doesn't get let out. Before I get too far into it, this is you guys probably can't see that. It's a model number AFI 2538AEB, as in boy. Looking at the fridge's backside, we can see our control board here. This is covered by a metal plate, which was bent up, like someone had already been in here and tried to mess with it. But it looks undamaged. But let's plug it in and see what happens. I really should have taken a picture of this fridge before I cleaned it. So bad. Okay, I feel the condenser fan motor running. I did hear a pop on this side though. Did something explode? Okay, all the lights are on the inside. I think I hear the compressor running. Let me take that bottom panel off and check it out. Okay, got my impact driver. Alright, so now my current suspicion, I've let this thing run for a couple minutes, is that this thing probably has a refrigerant leak somewhere. And here's why. So I can feel that our compressor is running. It's vibrating ever so slightly. It's not making any strange noises. So the starter is working, and the computer is sending a signal to the starter to run the compressor. Now, this small line exiting the compressor, this is the liquid line. Refrigerant comes out of here, goes into the condenser, which is under the refrigerator, where it turns from a, I guess this is really, it is a liquid line, but it's really a superheated vapor line. The superheated vapor refrigerant comes out of here, goes to the condenser coil under the fridge, and it condenses back into a liquid. It comes up into this filter dryer and into this little capillary tube to go to the evaporator coil. Now, I did say superheated, right? So that, I mean, it's not going to be really, really hot, but it's going to be heated above its normal boiling point. And this line should be warm coming out of the compressor, and it is not. Now, it will get naturally warm just because it's attached to the compressor. As the compressor warms up, this will warm up. But this should warm up pretty quickly as the fridge is running, and I just don't feel any warmth on it at all. Also doing another quick visual inspection. It looks like this, I don't know, some of these components look awfully clean for a fridge this old. Could be wrong there. But yeah, so I'm guessing this thing probably has a refrigerant leak somewhere. Is it worth troubleshooting that? I don't know. I mean, maybe I'll look around here to see if I see anything obvious, but if it needs a coil, evaporator or condenser coil, it's going back to the curb. Just for giggles, let's hook up a bullet piercing valve to this section of line right here, this process tube, and let's just see how low on gas it is. Okay, I'll leave a link to one of these things in the description, but they're pretty handy to have around. So I think we'll go after this straight section of pipe right here. What it does is it just pokes a little hole in that pipe, just enough where you can get refrigerant in and out of it. It's definitely not a permanent device. They do tend to leak over time. But just for quick diagnostic purposes or to confirm a problem, they could be really handy. Make sure you're on there. See it pretty firmly. I think it's fine. That's no bend anyway. Now, normally, the pressure on this process tube should be probably somewhere between 0 psi and maybe positive 5. So not a lot of pressure on the low side on these things. All right, that should do it. Let me get a gauge and we'll get hooked up. Okay, I got my field piece job link proof. I'm going to hook it up to this port right here. And you see that number right there, it reads 0.0 psig right here. So now I'm going to pierce the line by tightening the center screw. So you see the pressure jumped up a bit, 0.6. Oh, never mind, negative 12. So yeah, I was right. So we're pulling a 12.6 psi vacuum, which is not great. Yeah, because we want that to probably be between 0 and 5 on most fridges. That's just a general rule. So let me cut power to the fridge, let the pressures equalize. There probably is some gas in there. I want to get on positive pressure on this line right here, because if I unhook this to add gas to it, I'm going to draw in an atmosphere, and I don't want to do that. I want it to be under positive pressure. I guess I could just seal it off here too. I think this center thing seals it. You tighten it in all the way. Yeah. So let me get a charging tee, a hose, and some R134A. Wow. I'm not sure if you guys can see this, but our pressures are equalized to like 8.1 psi below, so negative 8.1. It might still be equalizing, but there is really no gas in this thing. It's pretty bad. All right, so I got this piercing valve shut off. Let's disconnect this bad boy. Gonna install my charging tee. This will allow me to keep my probe hooked up while I'm adding gas. And here I have what's left over of a can of R134A with a one of those valves there and a ball valve at the end. I already purged the hose, get all the air out of it, so we're good to go to hook up here. Just gonna leave these threads on a little bit loose, purge a little bit more. Okay. And then we'll loosen down here a bit and purge again. There we go. All right, now we're good to power the fridge back up, and we'll add a little bit of refrigerant to it and see how it reacts. Yeah, compressor's running. Let's open this valve to allow refrigerant to flow. Already pulled a healthy vacuum. Let's add some gas. All we gotta do is open and close this valve. You gotta add refrigerant slowly to these systems because capillary tube systems do take a while to react to refrigerant additions. But because this thing has so little gas, you need to start it somewhere, right? Could also have a very catastrophic leak somewhere. You're technically supposed to weigh in the charge. I think the charge is somewhere around 5 ounces on this thing. But yeah, I'm not going to go to all that trouble. This thing's probably going to end up at the curb again. And again, we want this number down here to be somewhere between 0 and +5. We're at -6.8 at the moment. Again, that's most fridges. That's just a guideline. I do feel this line heating up over here. This liquid line or superheated vapor line. Not a lot, but it's starting to get a little warm. So let me work on this a little bit. We'll get this thing in better shape. Okay, I found our refrigerant leak, and it's so big I can see it. So I can get you guys back there. So look at that line right at the bend. I'll see if I can put my finger on it without chopping my hand off on the condenser fan. It's right back there in that bend. I don't know if you can see the refrigerant venting out. My finger's on it right now. So it looks like what happened is over time, the corrosion on that pipe just ate a hole through it. You can see some oil down there too. So we got to pull that condenser fan motor and see if we can fix it. It's silly to put gas in it anymore. All right, let's see what it'll take to fix this thing. Maybe we can just get on there with the torch and patch it up. I don't know. Let's see if we can get this one out too. Anything else? Maybe take this whole thing apart, right? So how does this thing come out? Quickly realized there was no way to get that fan bracket out from the back, so it looks like this whole bottom pan comes off. So let's try removing this and see if that gives us the access that we need. Of course, it's held on with a Torx fastener. Oh yeah, that's the secret. Get you guys over here. Let's see if I can do this without knocking you guys around. Looks like it clips onto a bracket down here. Oh, so close. There we go. And it probably clips onto one there. Okay. Our fan is sort of free and our leak is right down in there. In fact, you can see the stains in the oil pan from the oil. Right there. So I wonder if we could just eliminate that whole section of pipe that's in the condensate. It's probably there to get it to boil off and not let it get too cool. Never was a huge fan of that technique, but let's spray some bubbles on there and see if there's still enough gas to trigger. Yep, you can hear it. At least I can. Get you guys closer. Hear that? So let me rummage around and see what size pipe I have. I wonder if 3/8 pipe would work there. If I just cut out a section here, cut out a section here, and just do it that way. I think that'll work out perfectly. So this looks to be 1/4 inch outside diameter copper tubing, and I have some 3/8 ID copper tubing, and the inside diameter is pretty close to 1/4 of an inch. Whatever's left over we can probably fill with solder. So I think that'll work out nicely. Got the old section of pipe cut out, and this is kind of what I was thinking, right? So this is the piece that was leaking. You can see the leak spot right there. I'll clean it up with a wire brush for you later. But I think this will just fit pretty neatly inside there. So I think that'll work. So I measured and I need 13 inches of this. I'm going to measure that and cut it off. Sorry I've been all over the place with this video, but I've just been kind of on the fence what I wanted to do with this thing. Do I want to fix it? Do I want to curb it? I think I said before, if it had a leak, I wouldn't fix it, but here I am fixing it. I guess part of me can't resist seeing a problem and not fixing it. All right, I'm going to try this repair using Harris Stay Bright number 8, which is a silver bearing solder. Link in the description. Not cheap stuff, but it works really well. It's rated for HVAC use. So I'm going to put some flux on these lines here. I already cleaned the inside of the repair pipe. I'm going to see if I can work from this side. Hopefully you guys can see then. And kind of just crimp it in place. It's not going to be the easiest repair to do. Maybe something like that. And then can I squeeze this pipe to tighten it up a bit? There we go. Stay Bright 8 is not the greatest at gap filling. So we'll close the gap manually. Do the same thing on the bottom. Let's light that up with the torch and see what happens. Just going to use a regular MAP gas torch. I could do oxyacetylene here, but my concern is there's so much stuff in the way. Probably set something on fire, and I may even do it with the MAP gas. Pretty cramped area. There's that. Turn the fire down a little bit. The bottom side. And if I used oxyacetylene, I'd have to flow nitrogen too, which I am not set up to do at the moment, so that's another reason why not. I know you guys can't see this, but I'm doing the exact same thing on the bottom side. So I think we're probably good to pull a vacuum, get this thing hooked back up, and see if it works. I should be replacing the dryer, but I don't have one in stock, so what I'll do is I'll see how this dryer works out. If it's toast and we can't get it to cool, I'll order a dryer for it. All right, let me get things buttoned back up here, get this bottom plate back on, and get the condenser fan back on. Then we'll pull a vacuum and see how she runs. So I'll catch you when everything's put back together. All right, I'm all set up to pull my vacuum on the system. I got my JB Eliminator vacuum pump down here. Hose by Appion. 2 Appion valve core removal tools. Valve core is removed from this Schrader here on the compressor and on the process port. I did swap that out with a proper process port, not one of those bullet piercing valves. And I have a T here because this thing is not rated refrigerant contact. So when we gas it up, I just want to be able to isolate that thing. And in fact, I guess we're probably ready to get going. Also hooked up my yellow refrigerant charging hose to a new can of R134A. Just so I can break the vacuum with refrigerant. And that ball valve right here is closed off. This line is purged, ball valve's closed off, so we should be ready to start our vacuum. If I did have a spare dryer, I would be hooking up another hose to the secondary port on the dryer, because a lot of dryers come with high side probe ports, so you can vacuum from both sides. But I'm not going to do that here. Again, this fridge is trash picked. I'm not going to spend a whole lot of time and money on this. I've already spent way too much. Contact. All right, let's watch our vacuum gauge, see how we're doing. Getting close. 71,000 microns, 6454. We'll let that run for a little bit. And in the time it took me to move you guys over here, we're down to 600 microns, 570. We'll exercise these valves a little bit. Sometimes you get air pockets in them. The gauge probably went up. Not really. We'll let this run for a while because this thing was pulling a vacuum for quite some time. By that I meant the compressor was pulling a vacuum for quite some time because there was no refrigerant in the system. Okay, I've been running for about 10 minutes or so. You see we pulled the vacuum down to 260, which is really good. We want that to be below 500. So I'm going to turn off this valve, isolate the vacuum pump, and we'll let that sit for maybe another 10 or 15 minutes or so, just to make sure it doesn't come above 500 microns. So, see you in 10. Okay, it's been about 10 minutes. Our micron gauge is holding steady at 230 microns, so I think we can be fairly confident the system doesn't have any leaks. I've got my refrigerant scale lined up, zeroed out, and we have to put 5 ounces. Well, 5 ounces is the factory charge, but we're probably going to have to put a little bit more in because that line that we use to do the repair is 3/8 OD, or 3/8 ID, and the other one, oh wait, no, it's 3/8 OD. Yeah, 3/8 OD, 1/4 inch ID, and the pipe we replaced was 1/4 inch, so it's going to be a little bit more room for refrigerant in this system. So we'll stick it up to 5 ounces and see how things look. Okay, so our first step, let's isolate our vacuum gauge. Turn this ball valve here. And what we'll do is we'll put some refrigerant in the system to break the vacuum. We'll do that by just going like this. Let's look at the scale. Got 1.4 ounces in there. We're not going to be able to get all 5. We'll have to turn the system on. But again, our goal right now is just to get it to positive pressure. So it looks like 1.8 ounces is all it's going to take for now. So now let's put our Schrader valve cores back in. Take off the micron gauge. Won't be needing that anymore. Set that aside. Here. A little tough to do one-handed. Put light pressure on the back and turn with the other hand until you feel it seat. Okay, so that one should be good. Let's just make sure it's seated. We'll crack this ball valve. We should get a puff of refrigerant and that's it. Yep. So that one's good. Now we're going to do the same thing here and put the valve core back in there. Let's go ahead and disconnect our vacuum pump. And we'll put this Schrader core back in. Open this valve. And we'll thread this one back in as well. Okay, feels like it's seated. And we should just get a puff of refrigerant. That's it. So we got 2 ounces in here, roughly. Now we just got to get the rest. All right, just moving things around a bit caused the scale to go up. So it was on 1.8, it's on 2.8. So we gained an ounce. So we'll put in wait, what's 1 plus 1 minus 2? Carry the 6 divided by 12. Let's just re-zero it. So now we got to add, what, 4.2 ounces? So let's see if it takes any more gas, just like this. Zero it again, I didn't do anything. Come on, 0. Okay, there we go. Just going to open that ball valve. Taking a tiny bit. Not a measurable amount. All right, let's plug it in. It should be a lot more willing to take refrigerant then. Fridge is plugged in. Compressor is running. Let's add some gas. Okay, hooked up the pressure probe just to keep an eye on things. We're at 0.6 ounces, so we have to go to 4.2, and we're at -6 on suction size. Let's add some more. It's kind of a slow process, right? We've added a total of 1 more ounce, so 2.8 total. .2, 1.4, reading the scale while you guys are looking over here. 1.6, 1.8, 2, okay, we got positive pressure. On the suction side, we're positive 2.6 psi. I've added a total of 3.8 ounces. Let's add some more. That can's starting to frost, so this might take a while. I could stick the refrigerant can in some warm water to warm it up, but then I don't want to mess with the scale. So I'll sit on this and I'll work this ball valve until we hit what, 4.2 on the scale. Sorry about that. I don't know what I was thinking earlier when I said 4.2 ounces. Jeez, guess I hadn't finished my coffee yet. Anyway, so needed to add 3.2 ounces, but I added an extra 0.2 ounces because of that larger line that we spliced in. Our suction pressure is just under 10 psi. It's pretty warm in the garage. It's pretty warm inside the fridge, so I'm happy with that. So I think we're going to go ahead and disconnect our refrigeration equipment and probably just finish putting it back together. Yeah, so this is, whoops, tablet just went to sleep. That's kind of where we're at pressure-wise on the suction. It's a little bit beyond that 0 to 5, but you know, every fridge is different, and obviously it's pretty warm in here, so that's going to affect things. All right, it's a couple days later. The fridge has been running great, actually. The freezer gets down to about, you know, maybe a degree or two below 0, which is right what it should do, and the freezer section stays at about, you know, low 30s or so. Sometimes it dips below freezing. So yeah, I'm getting ready to button it back together. I did end up swapping out the starter for the compressor. I got one of these universal, you know, starter kits that's compliant with a run capacitor. I'll put a link in the description. Just got to zip tie these wires up and make things a little bit prettier and more secure. But other than that, we're good to put this panel back on. So let me zip tie those together. Hey, buddy. And we'll put the fridge back together. Okay, got these wires zip tied up here. Got this capacitor just kind of sitting here. I mean, it's not perfect, but it's fine. Now we need to put this back panel back on. I think I got to pull these 2 screws to do it, if I remember correctly. Yeah, I'm pretty sure. And again, it's pretty important that you keep this panel on, or at least airflow over this area, because a lot of fridges are designed with the cooling of a lot of these panels are designed to be able to cool the compressor. So if you leave this panel off, you might overheat some. Whoops. These things are never fun. You get the idea. That's where our refrigerant leak is from, right there. You can see the crack in the pipe. Right there. Crazy, huh? Got all the shelving put back in and everything cleaned up. Got all the flies out as best I could, but yeah, this thing was a dumpster fire. Let's see how cold it is. It might be a little bit warmer than it should be just because I have the doors open, but so in the back we're at 34. That's perfect. We want to be above freezing. Let's check the freezer section. Watch out, bud. Silly dog. Freezer section, we are 31, but again, I had this door open for a while, so. It's a couple minutes later. Let's check the freezer now. Should be nice and cold in there. Yeah, 1 degree. You guys probably can't see that, but yeah. So this repair was not an easy one. So a lot of the fridges I trash pick, you know, they might need a compressor starter. They might need, that's actually a pretty common one. But yeah, this one had a genuine sealed system problem. I realize that not everybody has the tools or the knowledge or even the desire to take on such a repair, but this tiny little crack is what brought this fridge down. And was able to fix it with everything I had in stock using tools I already had, and turned this junker into something that's usable and kept it out of the landfill. That's honestly why I do a lot of this stuff, because this fridge still has life left in it, and if I didn't do this, it would end up in a dumpster or in a landfill somewhere. You know, the refrigerant already leaked out of it, so it's not like I created a new problem. Actually, arguably saved the environment here. So anyway, enough babbling. If you found this video helpful, please subscribe, stay safe, and thanks for watching, everybody. Take care.